Hi, today we would be learning about solid principles. So before we learn about solid principles, let us understand a bit about what actually working in software development industry means that. So let's say we have a product to convert JPEG format to PDF format, and then we found out the product is performing well. Okay, so then we hired more developers. So I can say that this is a teamwork thing. And the very next thing is, then we thought that why just convert JPG to PDF? Why not convert MP3 to some other format? So why don't we work on audio change format also? So change is a very small thing. Now let's say on day 1 there was support of only one feature. On day 100 there are 100 of features. So the company might grow big. It should be able to handle a lot of changes, and the amount of time required to make these changes should also be less. That is why it would also grow big. So to do this, for in most of the startups or in most of the software development life cycle, we use object oriented programming rather than procedural programming. So if we are using object oriented programming, then I can say that it should be readable for the other developers also. It should be testable also, like it can be easily tested and moved to production. And it can also be extensible, like tomorrow a new feature can also be added. So this solid principle is nothing but a set of rules which facilitate these all things because of these all requirements. So we have a set of requirements in SDLC, that is software development lifecycle in real life. And to facilitate that, we have these all requirements, and solid principles are a set of rules which fills up or rather compels us to meet these requirements by default, and it applies to only object oriented programming. So now solid principle is nothing but it is also an acronym, like S stands for something, O stands for something, L stands for something, I stands for something, and D stands for something. Now what is this something something something? Let us unwind it one by one. So the very next one is single responsibility principle. Very easy to understand what it means. It just means that a class should have only one job to do. But the difficult part is, why does this rule applies and how it would facilitate the software development life cycle or SDLC in real life? It is because if a class does only one job, okay, why does it exist in the first place? So let us see how we can do that. Let's say we have a class, okay, which calculates the salary also, and it generates the report. Single responsibility principle tells us that we should break it down to do different classes, and each class should do only one job. This is how we can do it. But what does this facilitate? The very small point it facilitates is specific test, unit test. So what do you mean by unit test? Every logical implementation of program that can be isolated, we can write unit test over it. So this employee class, we can write unit test to calculate salary. We can directly do unit testing over this class, and we can directly do unit testing over this class also. So tomorrow if we have a class which does two things, then we have two different dimensions of unit test, or we would have different subset testing. So that is why to have better unit testing and to have separation of concern, let's say tomorrow the report generation process changes, then we don't really need to test this calculate salary. Only the report generation process changes. Then we only need to run testing for report generator only. Also, yes, we have subset testing, so we should have test cases, then we should segregate them to have subsets and then use subset. But we don't want to go in that fashion. We can directly run unit test over this. Then the very next one is that if a class, like let's say this is a very big project of employee one, okay, this is a very big project. As of now, we have a habit of just giving all the logic to the employee class. So now it would be very difficult to keep track. Tomorrow a new developer came up and he added one more logic. Tomorrow and he added one more logic. And subsequently the test cases needs to be also. So it creates a conflict of interest. Like whenever we have a roommate in our home, we say to him, na, this is a table and I keep important stuffs over here. So if your roommate starts keeping unimportant stuffs over here, it would become frustrating. Or if anyone comes at your table and keeps anything you wanted, it would be problematic. In the same manner, if a class doesn't have only one concern to solve, anyone can come and he can just write his code or logic over here, and this would create conflicts. So very first one. And the very next one is easy version control. Okay, let's say this is me, I make mistakes. So I coded up this generate report. Okay, and when it went to the production, some users were facing an issue with generation of report and there is no one to work upon. So a senior software engineer came on his weekend and he just unwinded code of generate report, and that solved the issue to the earlier working. Okay, now the product is again stable to its previous form. But let's say if it has multiple concerns and queries, if this employee class has multiple concerns, then he can't really just unwind this employee class to calculate salary or report generator to report this. He can't just simply unwind this. So he needs to see if any other thing is getting affected or not. So easy version control. And then we have a concept of merge conflict. What is basically merge conflict? If you have worked on personal project, this is not a thing that I expect you to see. But if you worked on a real world industry project, there would be merge conflict. Why? Because this is the employee class. I said that this would do the work of ABC. Someone else said that it would do the work of ABCD also. So this creates merge conflict. So if we have a separation of concern, then a person who is changing the logic of calculate salary would change here, and a person who is changing the report generation. So less merge conflict. So this is why single responsibility principle exists in the first place, and this is what is single responsibility, and this is how we implement or enforce single responsibility principle. So now the very next one stands for SO, that is O. So open closed principle. What this is all about? What this small squeaky little thing is all about? It is saying that a class should be opened for extension but closed for modification. Like you shouldn't modify the previous classes, rather you should just extend it. And comparatively understanding this is simple. Why we are doing that? Because if we are extending a functionality, then the original object remains the same. So we don't need to retest this original, but rather just check the new functionality. Imagine rolling out a new software update for just Google Calendar and testing the whole Android for it. Just imagine the heck it would be. That is why we should only extend it so that the original working remains the same and only the new feature needs to be retested. So the only why it exists in the first place is retesting of the old functionalities. And the very next thing is, seems good enough, but how do we do it? We do it using abstract classes or interface. That is, we have an abstract classes on top, and this is the original product, and we just inherit it and bring a new product. Okay, now let us see a real life implementation. Let's say we have a payment processor. So as of now, we accept only credit card and PayPal. Tomorrow our product is receiving a lot of payments, so we need to add support for more types of payment. So here only we are again editing this. So tester assigned for it would need to test for credit card also, PayPal also, and the new one also. What should be the correct way to do that? The correct way to do that is, I just declare an abstract class which would say process payment. Okay. So now anyone who wants to be eligible as a payment process would just need to be implementing extend payment. So if you observe this, we are not touching this class. That is, if the code is not changed, then we don't need to test it. PayPal payment. So let's say tomorrow a new type of payment comes up, then new thing appears. So we have a payment processor which would just accept and call the process payment. So this facilitates this. One very important thing, that is why I have wrote VI over here. If you observe, what is the mistake in the first code? The mistake in the first code is that we are using concrete implementation. But if we had on the first hand itself, if we use abstract payment, then we could have already done this. So see, if you have a code like this, then you need to first convert it to this form and then start extending it. So conversion is a pinpoint over here. A conversion is painful over here. Okay. So this makes us move to something known as dependency injection principle. So dependency injection principle says that, what was the pain there? The pain was there that we had to restructure the class to obey it through abstract classes and interface. We had to restructure it. So dependency injection principle says that don't restructure it, but do it in the first place itself, so that you can obey open close principle when your product enlarges. So that is what dependency injection principle says, that a classes should depend upon interfaces and abstract classes. Okay, like it should, on the first place itself, it should already, the restructured code that we brought over, that should be the first form of implementation. Okay, rather than concrete classes or functionalities. So dependency injection principle exists on the first place to enforce open closed principle. Okay, it just said that don't directly use concrete implementation, but every time just use abstract classes or interface. Why do we need to use abstract class or interface even though we don't need it? Because tomorrow if a new change comes up, we can only extend that behavior but won't modify it. This is what is known as dependency injection principle, exists in the first place. Now the very next one is Liskov substitution principle, and make sure you hear this in a very calm mind, because this is absolutely very necessary. Okay, now let us see what is Liskov substitution principle. So Liskov substitution principle states that subclasses should be substitutable for the base class. What does that mean? Before we go to what does that mean, let us understand with the help of example. Let's say this is my father and he did a lot of good work, he had a lot of reputation. Then I, as a child of him, should not lower down his reputation. Rather, I should increase his reputation and keep on with the legacy of good reputation. Make sense? Same thing is told by Liskov substitution principle also. Like a subclass which is inheriting from a base class should extend the functionalities of this but not narrow it down. So now what does that mean? Again, in a very descriptive manner, any method which expects class A should also be able to expect class B also. This is what. Now why does this exist in the first place? Why we'd only need to broaden the functionalities but not narrow it down? Why do we need to do that? Because that is the correct form of inheritance, and this principle exists to enforce correct inheritance. Okay, now let us see this in action, where this is the very first code. We have a rectangle class which has a setter of width and height. Then we have a get area class which just calculates the area on width and height. But see, this is a rectangle, and then we have a new square in the game. So square is nothing but a specialized form of rectangle. Here would be the subclass, and rectangle should be the base class itself. Make sense? Similarly, so see, we implemented it. Set width, which would set the width of it. Set height, which would set the height of it. But let's see the problem here. What are the problems here? So see, rectangle responds in the correct fashion he is expected. But see, let's say on square, we just pass set width to it, and then we pass it 10, and then same square, set height to it, then pass it 15. Then again it sets the height of it to 15, height and width both would be set to 15. So if you observe, this sets both of them. So if you see, this is unnecessary because height would set both of this thing. So we are not extending the functionalities, but rather we are limiting it. So what is the correct manner in which we should do it? The correct manner which we should do is, we should have a shape interface where we would say that we have a get, anyone who is implementing get area would be eligible for a shape one. So a rectangle implements the shape, okay, and it also has get area, which just returns the area, okay. A square also returns the area. Now if you observe, as shape is implemented by rectangle also, by square also. So now any function, dynamic method dispatch, you heard that? If you have not heard that, Google it. So any function which expects shape as a parameter can now also expect rectangle, and it can calculate the correct area, can also expect square, and it would also get you the correct area. So this is how it should behave. Both the parent and the child are able to get the area correctly. Now the very next one is that interface segregation principle. What does this say? This say that you should have separation in concern when creating interfaces. Okay? Separation in concern when creating interfaces. Now there are two terms you would heard a lot in your explanation, so know those. The very first one is a fat interface. An interface which contains unnecessary method is known as fat interface. Tailor-made interfaces and interfaces which have the needed methods is known as a tailor-made interface. Now let us see a problem if we don't use this. So let's say we have a parking lot interface which has a method to park vehicle, which has a method to calculate fee, which has a method to process payment. Let's say tomorrow we want to do some free work also, because the company is generating a lot of revenue every now and then. So we also introduced a new concept of free parking lot. So now if you observe, the free parking lot would have park vehicle, but calculate fee, we can make it return 0, and process payment we can do nothing because it is a free parking lot. If you observe, these two are the unnecessary implementation we are doing it for free parking lot. That is why we should have tailor-made interfaces. How we can have tailor-made interfaces, Siddharth? Let us see that. We can have a basic parking lot whose just job is to park vehicles. How we have segregated this? Because we know at whatever the type of parking lot it is, it will always have a method to park vehicles. That is why we have included this in the basic one. Next, we have a paid parking lot, which extends basic and then says that additionally include calculate fee and process payment. So now if you observe that for implementing a free parking lot, we just need the implementation of a basic parking lot. and this is the correct form of this. So we avoid fat interfaces and we have tailor-made interfaces for this. So this is what it is all about. Solid principles. Thank you everyone.